In homework number 8, we talk about solving quadratic equations using the square root property. Now, remember what the square root property says. It says that if you have your variable or some variable expression squared is equal to a number, then that means that x is equal to plus or minus the square root of that number. But the key thing here is that you have to have the square completely by itself. So in number 1, the square is not by itself. You would first want to divide both sides by 2. Once you do that, you have x squared is equal to 32. And according to the square root property, that means that x must equal plus or minus the square root of 32. Now, a lot of times what some people will do is they'll just take this guy right here and say, oh, I'm just going to take the square root of both sides. And that's really not a problem as long as you remember the plus or minus right here. So, we have plus or minus the square root of 32. You want to make sure that you do simplify this. 32 breaks down to be 16 times 2. There's your perfect square. Now, you already have the plus or minus out here. This plus or minus is this duality of signs for whatever the answer is. So I've got the square root of 32. The square root of 32 is 4 square roots of 2. So the plus or minus goes on the outside. Make sure you write it this way and not 4 plus or minus the square root of 2. See, this is bad. The square root of 32 becomes 4 square roots of 2, not 4 plus or 4 minus the square root of 2. So be very, very careful how you write your answers. Now, having that plus or minus means you could separate this. And you could say that x is equal to the solution set negative 4 square roots of 2 and positive 4 square roots of 2. You have two distinct solutions here. All right, well, let's look at this next one. Look at number 2. Number 2 says x plus 3 quantity squared equals 25. So what you need to notice here is that the only place you see your variable is right here, and it's contained inside of a square. So in order to undo the square, that's when we do that square root property. But you must remember to put your plus or minus right here. Don't ever forget that. Now, this only happens whenever you are taking the square root of both sides, using that square root property. So here, this is just going to give me x plus 3, and this is going to equal plus or minus. When we simplify the square root of 25, we just get 5. But you want to make sure that you get x completely by itself, so you've got to move the 3 over. Now, when I do that, notice that I already have the plus or minus over here. And the general rule of thumb is whenever you move things over and there's already a plus or minus, you want to make sure that it goes before the plus or minus. So this would be negative 3 plus or minus 5. Now, as you look at this answer, you'll see that there is nothing that's imaginary and there are no radicals here. And what that means is that we need to separate this and get our two answers, because there will be two distinct different answers. Just like the last problem, this is going to be more simplifying that we can do. So this means that x is equal to negative 3 plus 5, or x is equal to negative 3 minus 5. When you see this, you see, oh, there's more work that can be done. Negative 3 plus 5 is 2. Negative 3 minus 5 is negative 8. So we get the two solutions that we expect from this quadratic equation, but there's not a plus or minus anymore, because when I separate that, you see that I get two answers. They're not a plus or minus. In the last problem, we had plus or minus 4 square roots of 2, and when I separate that, they really look the same. They're just off by a sign. But the solutions here, 2 is not 8. Let's move ahead to number 3. One of the things you always want to make sure that you do is you get the square by itself. So this guy is not ready. You first need to move the 11 to the other side. So just subtract 11 on both sides. And when you do that, you end up with the square completely by itself on the left. On the right side, you end up with a negative 9. So now that you have the square by itself, we apply the square root property, remembering plus or minus. So on the left side, this just gives me x minus 10. On the right side, we have plus or minus. And remember, the square root of 9 is going to be 3, but the negative inside gives you an I on the outside. So x minus 10 equals plus or minus 3i. And in the last problem, we saw that when we move things over, it needs to go in front of the plus or minus. So x is equal to a positive 10 plus or minus 3i. Now, you could try to separate this, but if you separate your two answers, there's nothing really special about this. You get 10 plus 3i and 10 minus 3i. There's no more work to do. And it's always going to be that case. There won't be any more work to do if you have anything that's imaginary or radical. Case in point, this next problem. This next problem has the quantity 2x plus 7 squared equal to 13. So when we look at this, you see that the only place that you have an x, that you have your variable, is inside of the square. So we can, and we already have the square by itself, so we can take the square root of both sides using the square root property, and there's your plus or minus. So that means that 2x plus 7 is equal to plus or minus. The square root of 13 is, well, it just is what it is. 13 is a prime number, so it has to stay this way. But now you have some extra steps to take here to get x by itself. The first step is to move the 7 to the other side, and that's by subtracting 7. So minus 7 plus or minus the square root of 13. And to finish getting x by itself, just divide everything by 2. And there you have it. X is equal to negative 7 plus or minus the square root of 13 all over 2. Now you could try to simplify this, but there's nothing more that you can do. And when it does come to simplifying, you can only simplify common factors that are common to all three of these terms.